This video is going to talk about the basics of writing a CNC program. Now, you should have already watched this video and you would have seen this worksheet off to the right side of the screen here. This is very important for the very basics of starting a program. This guy does a pretty decent job of explaining the roles of some of these different codes. So please make sure you watch that before you attempt this assignment. Now I'm going to do a sample program. The one you're going to do is going to look like this, but I'm going to do a simple one to kind of show you how everything works. And I'm going to use something that we've done before. This is one of our previous assignments. Actually, this one was where you put in the point-to-point code. So we started at point 1, and then we moved to point 2, 3, 4, 5. The only difference that we're going to do now is instead of just reading the points, we're going to be programming a machine to cut this square. Now, if you think about it, once I bring this into real life, I'm adding the third axis or the z-axis. So I'm going to have z codes in here as well. But these x and y codes are absolutely important, and I'm going to need to transfer these over. So here is my program. I basically cut and paste this from the assignment that you're going to do. These are all preparatory codes to get the computer to do what I want to do. The first line is the program. The second line is a basic home position. It's getting it in position to do a tool change. This is what's known as an insurance line, where it's making sure everything is in the default selection stages. This is the tool change to get the right tool that I want. This is telling the computer how far between the tip of the tool and my workpiece. And this is telling the computer to go to 0, 0, which would be like right here, to turn the spindle on to 3,500 RPM. And now at this point, we're ready to start cutting our points. So what I'm going to do is I'm going to enter the X and Y coordinates for all these points that I've done before. So the first one is 3, 3. So point 1 is X3, Y3. And then 2, 3, 4, and 5, I can almost just cut and paste right in there. Okay, let's try this. 2, 3, 4, 5. Let's cut it right in there. Okay. Now I do have to think about the z-axis, right? So if I want to do just this square, I have to go to this point. When I get to point 1, then I have to move z down. And we're going to move it down 0.05 inches, and it has to be negative 0.05 inches into the material. Then I go 0.2, 3, 4, 5, and then I have to lift it back up. And then we're going to go to 0.1 from there. That is a very simple program, but I want to check it, so let's cut it and paste it into our viewer. All right. Now let's plot it. Let's see what's going on here. Okay, so if I look here, I'm starting at 0. I'm moving to X3, Y3. I'm going to my points. I come back, and then you'll notice that it lifts up. It doesn't come in contact with the material anymore, and it goes back home. And that's exactly what I wanted to do. So after it does its cutting, the bit retracts above the surface of the material, and then we turn this coolant off. We go to a Z safe distance. We bring the spindle up. We turn off the spindle. We go home, and we're setting into incremental. Then we end the program. This is a very, very basic program, but you can tell by the viewer that we're doing exactly what we want to do of cutting that square. So this should serve as an example so that you guys can go ahead and apply the same methodology to this. And the only difference here is there's a couple more things going on. If we look at the point diagram here, we start and end at 0, 0. So this is point 1 and point 8. Point 2, we drill a hole. So we have to go down and up with our Z. Then we move to point 3 and do a hole, down and up with our Z. Then we go to point 4, go down with our Z, move to 5, 6, 7, lift up, and go back to 8. So the only thing we have to be careful here that we're doing that's new is we're adding Z movements. Now, for the Z, it actually tells you here how far down to go down. How far to go down, excuse me, 125 thousandths, 0.06 thousandths. So we just have to be careful and read this diagram, and it has all the information we need to complete this.